Define study objectives. In this video, we'll define generative study objectives and we'll explore objective options. In Fusion 360, we want to carry on with our generative suspension design. At this point, we have used our construction plane to set up a symmetry plane, as well as our preserve and obstacle geometries, and we've included our loads and constraints in load case 1 and load case 2. The next step in the process, after we've set up the design space, is to talk about design criteria. First of which is going to be our objectives. The objectives are going to give a focal point for all the generative outcomes to narrow down to. These are going to determine whether or not they converge on a specific outcome or whether or not they complete without reaching their goal. So these objectives and limits can include a whole host of different options. For our example, we're going to first focus on the objectives and the limits, and then we'll talk about some of the other options. The two main options that we have for our objectives and our limits is to minimize the mass, which will target a safety factor, or to maximize the stiffness. When we're maximizing the stiffness, we're going to be focusing on a target safety factor in addition to a mass target. In our case, we're going to be looking at a lower A-arm that's going to be 10 pounds or less. When we do this, we need to enter LB or LBS as the unit, and you'll notice that it's not taking it. But if we have this drop down, we can enter various values that have been previously loaded, or if we want to change the units, we can set the units up inside of the unit dialog in the browser. So for mass, we can set this up as pound mass, which is LBMASS. So if we wanted to manually enter that, notice that we need to follow that same suit. So 10 LBMASS. Once we enter the correct designation for one of the other units, then it accepts it as a valid option, even if it's not set up in the current unit system. So this option allows us to again focus on a safety factor, which will determine the loads that we applied, and it's looking at a failure criteria, whether or not we're going to exceed plastic deformation, or if the part is going to permanently deform. And then it's going to double those numbers. So if we applied 1,000 pounds, it would need to exceed 2,000 pounds before it actually permanently deformed. So that's our target, and we're putting 10 pounds mass, which is relatively heavy for our design. But again, it's going to give us a nice amount of material and something that we can work with. The next thing that we want to talk about is some of the additional options that we have inside of our objectives and limits. The first of which is modal frequency. Notice that activating modal frequency does not discount the maximized stiffness that we already set. This is going to place additional objectives and limits on our studies. This means that the outcomes will not only focus on a factor of safety of 2 and a mass target, but they're also going to be looking at modal frequency. When we're looking at modal frequency, these are generally going to be frequencies induced by, in our case, either road vibrations, vibrations from the suspension, or from the engine that's being used in this design. Because we don't have data to support this for this example, we're not going to be using modal frequencies. But note that you can always create simulation studies after the fact and analyze how your design does in those areas. Next is displacement. If we had a minimum local or global displacement in certain directions, for example, if X and Y are not important to us, but we need to minimize the amount of displacement that happens in the Z direction where most of the loading is taking place, then we can enter a value here, and it's going to factor that in when it's looking at maximizing stiffness. So displacement is another metric that we're going to get, regardless of if we set it up as one of our objectives or limits. And the last option that we have here is something called buckling. Now, buckling is another simulation study that we can set up after the fact, and we can look at how this performs and deforms based on certain loading criteria. Again, all of these can be extremely important factors, and it really depends on what you're trying to design and what information you have available. For our case, we're going to focus on maximizing the stiffness with a safety factor of 2 and the mass target of 10 pounds. We're going to say OK and make sure that we do save this design before moving on.